right. Yeah. Hi everyone. I'm going to talk about this work on verified reversible programming for verified lossless compression that I've been doing with Jan-Willem over in Amsterdam. So why am I interested in reversible programming? So in my kind of day-to-day work, if you like, I kind of design and implement new lossless compression algorithms. And a lossless compression algorithm actually always contains two functions, an encoder and a decoder. And we require these to be exact inverses to each other. That's where the losslessness comes from. So I've got some Python code that kind of exemplifies the type of code that I might write. So on the left, we've got an encoder, and on the right, we've got a decoder. And I won't kind of go into the details here. What I want you to observe is like the high-level structure and the fact that there's a correspondence between these two functions. So the middle operations correspond to each other, like the top operation of the left-hand function inverts the bottom operation of the right-hand function, etc., etc. But there's actually a bug here. So I put this in to kind of illustrate the kind of bugs that happen in the programs that I write. I don't know if anyone spotted that, but I think those bugs are quite hard to spot by eye. And to find them, you often have to kind of do this manual bisection process where you pause the encoder in a certain state, pause the decoder in a certain state, and check that everything matches. And you kind of effectively do this like binary search through the programs to find out where things are incorrect, and it's a real pain. So there's a question of like whether we can prevent that kind of bug automatically. And I guess more conceptually, like it feels like it ought to be possible to express both of these functions in one function, which can be both done and undone, i.e. a reversible function. So I've written a tiny language, which is a pure functional language embedded in Agda, which I've called Flipper. This is a kind of high-level overview. I'll start in the bottom right. So this is the type of reversible functions, and it's a record type. So to build a reversible function, you have to write an apply function, which is the sort of do, an unapply function, the undo, and then these two proofs of correctness. So the first proof says that for all A, unapply of apply of A is equal to A. And then the second proof says that apply of unapply of B is equal to B. So they're kind of obvious bijection properties. This type is often called an isomorphism in the functional programming literature. And then, so how do you make one of these? Well, you can build one manually yourself if you want to, but that's kind of boring. So what's more interesting is that I've written a sort of little compiler as an Agda macro, which takes an implementation of apply and basically generates the three other record elements automatically. And it turns out for this like small grammar, if you kind of express your function in this particular way, then those three things are actually pretty straightforward to generate. But this language is general enough for my purposes. So it's a very selfish project. I'm really doing this just for myself. This is general enough to express the lossless compression methods that I want to implement. I've got a tiny sort of trivial example here. So this is a reversible function that swaps the elements of a pair. So maps from a Cartesian product reversibly to this other Cartesian product here. F is that compiler macro being applied to a lambda. And one thing that's quite nice about Flipper is that you can see syntactically what the result of reversal is going to be by rotating the source code. So that's where the name Flipper comes from. And actually you have to do this two-stage kind of physical transformation to the source code. So you firstly rotate it, and then you have to upright each symbol. And that includes the constructors, so those commas have to be uprighted. And you have to move the lambda over to the left. So the lambda actually that's kind of an ugly thing, but anyway, this is the unapply that you get by so it's global rotation followed by local rotations. Okay, so that's kind of it for the talk. a few things. Oh yeah, still need to finish the compression implementation, but it's all finished. It just needs to be sort of glued together, and I need to set up I/O and stuff. Maybe like make Flipper into a standalone language. So there are some slight limitations due to the way that it's embedded in Agda. In particular, some things which it should be straightforward to prove that they terminate. Agda's termination checker actually doesn't do that. So you have to like shout at the compiler in capitals terminating to sort of say this function does terminate. Yeah, and I'm also on the lookout for other use cases of this reversible language. Anyway, yeah, that's it. Thanks very much for listening. It's all on GitHub here.